and we are looking at question 21. So you have a car rolling along a smooth, level road with kinetic energy of this, rolls up an incline, comes to rest at point B. So here is my picture. There's point B. It kind of got cut off a little bit. The kinetic energy at point A is 3.84 times 10 to the fourth joules. As one of my students said, are you just trying to annoy us with this? And the answer is yeah. You'll see this is called scientific notation in chemistry next year a lot. And we want to start to get you used to seeing it some. So it asked for A is what's the velocity? You know the kinetic energy. You can plug in, you know the mass, and you find out that the velocity is 8 meters per second. Now, at B, for B, it asks what's the height that it reaches. And the height that it reaches is all about looking at the different types of energy. So I know the height at A is 0. I know the velocity at A. I don't know the height at B. I know the velocity at B is 0 because at the highest point it will have rolled, slowed down to a stop, and then if we continued going it might roll back down. But all of the energy would have turned into gravitational potential, no more kinetic energy for that. So I look at this and I know that total at A is equal to total at B because there's nothing interfering, or that's my assumption. Looking over here, I know there's no gravitational at A, no kinetic at B. So the kinetic at A, 38,400, that's equal to the gravitational potential energy at B. And putting in the numbers that I know, I can find out that the height of B must be 3.2 meters. Now, C, I ask you to say, if we doubled the velocity at A, what would happen to the height that it would go to at B? So, the velocity at A is now 16. It's no longer 8, it's 16. And so how much energy does that give us at point A? Putting that in, and we get that we have 153,600 joules of energy at point A. Still no gravitational at A. And so how high does that let it go at point B? Well, if point B, all of it is gravitational, as we know, then we can say that mgh at B is equal to 153,600 joules of energy. And putting in the numbers we know, we get a height of 12.8 meters. So compare that to the answer we got in B, and it turns out to be 4 times the answer at B. And so it is this one that is the correct answer for C.